What is a power? What do you think of when you hear the word power?
Exponents.
You think of exponents. What else do you think of? Good.
Numbers.
Exponents. What else?
Base.
You think of a base. Excellent. What operation do you think of when you hear the word power? Multiplication. Good. Can someone give me an example of a power? Yes. 2 to the power of 2. How else can you read that? 2. We can read this 2 to the power of 2, or we can read this as 2 times 2. Good. How else can you read this? 2 squared. Excellent. You guys are smart. You got everything. When looking at this power, let's do 2 to the power of 3 this time. Which part represents the base and which part represents the exponent? What's the base? Good. This is the base. And then the number 3 is referred to as good. What do those two parts tell you? What does the base tell you and what does the exponent tell you? Everyone hear that? The exponent tells you how many times you need to multiply the base by itself. So the base is the number that's being multiplied repeatedly. So I'm multiplying the base. How many times? Good. So I'm going to rewrite the base 3 times. 1, 2, 3. And remember, we can use brackets to show multiplication. The reason I'm using brackets is because we're going to look at bases that have negative numbers as well. Well, if I were to ask you to solve this, evaluate, what's 2 times 2 times 2? Good. Okay. If I wanted to punch this in on my calculator, I would type in 2. How do you show to the power of on your calculator? What does yours look like?
The Y.
So it looks like this.
Yeah.
Okay. Who else has a calculator that has that button? Does anyone have a calculator that has this button? Okay. Does anyone have a calculator that has this button? It's either of these 3. Okay. 2 to the power of 3 equals, and then 8 should show up on your calculator. Make sure that you know how to use your calculator. How would I represent 2 to the power of 3 as repeated multiplication? Good. And what is the answer? We already did this one. Positive 8. Good. Now look at the next one. What do you notice about the base? And, good, it's in brackets and it's a negative. So you're going to put everything. This is the entire base. All of this. So negative 2, and I'm writing it 3 times. Okay? Because it's in brackets, it's everything inside the bracket to the power of 3. Well, what's a negative times a negative? A positive. Good. And what's a positive times a negative? So the answer is negative. Raise your hand if you got that one right with the negative. Good. What about the next one? This one's a little tricky because there are no brackets. So look here for a sec. This is actually the power. The power is 2 to the the power is 2 to the power of 3. But what's in front of the power? A negative sign, right? We have this negative symbol in front. So I'm going to keep that there. And then I'm going to actually solve 2 to the power of 3, which is 2 times 2 times 2 equals, what's the answer? Negative 8. Good. Negative 8. Okay? Because the negative is not in a bracket, the answer will automatically be negative. Actually, I want to do this one right here. So if you look at this, just as a side note, again, we have a negative outside the bracket. Here's my power. 2 times 2 times 2 times 2. What's the final answer? Negative. Good. If this was inside a bracket, the result would be positive. If the negative was inside the bracket. Okay, let's look at D though, before I confuse you even more. What do you notice again? There's a negative outside the bracket, and then we have this as our power. So we're going to keep the negative outside the bracket. And then, what's negative 2 to the power of 3? We did it over here. What's negative 2 to the power of 3? Negative 8. Right? Negative 2 to the power of 3 is negative 8. Well, we have two negatives together now. What does it become?
Positive 8.
Raise your hand if you got positive 8 for that one. Good. Excellent. Notice about each of these solutions. What happens as the exponent gets larger? Yep. The answer gets bigger, exactly. They grow very, very quickly. It grows very quickly. Now, the base here is a whole number. What do you think happens when the base is a fraction or a decimal? Do you think the same thing happens? It grows? 0.25, good. What's 0.5 to the power of 3? Pardon? 0.125, good. And what's 0.5 to the power of 4?
0.0625.
Good. Yes, you're right. Okay, what do you notice now when the base is not a whole number? Is 0.5 a whole number? No, it's not. Yes, what do you notice? It decreases, exactly. Even though the exponent's getting larger, the numbers are actually decreasing. Okay, they're getting smaller. So I want you to try this example now. What do you think is greater? So 1 to the power of 100 or 0.5 to the power of 5? I want you to calculate both of these and tell me which one is greater. Power of anything is what? 1. We have a base that's not a whole number here. What's 0.5 to the power of 5? Who calculated it?
0.03125.
Which one's greater, a whole number or a decimal?
Whole number.
So don't be fooled by how large the exponent is. It doesn't really matter. It's the base you want to look at as well, right?
Made with Doodlecast Pro.